Hi, and we're the team working on isCovid. Currently, the world is facing the COVID-19 pandemic, which has immensely impacted all lives around the world. And one of the most important things is our health. More importantly, we need to assess if we're infected with the virus. And when people go to the hospital, doctors need to be able to accurately diagnose patients because it is vital that they receive the proper treatment, especially if they have COVID. Our team worked together and divided the work amongst ourselves so everyone would be able to contribute to our project effectively. I worked on data cleaning, the random forest model, and the web application on the front end. Priyanka worked on the transfer learning model and the web application integration. Lalla worked on data cleaning, the CNN model, and the web application overall. Our team's solution to this problem is a web application that we created called isCovid. Now, this web application is based on an open database of COVID-19 cases, which contains chest x-rays, CT images, and some information on the patients. And with isCovid, we plan to utilize deep learning in order to predict if the patient may possibly have COVID-19. Now, overall, our patients' data that we used contained 406 patients. And while that may not sound like a lot, we were able to have multiple x-rays for some of the patients, and this data was extremely helpful in training our models. The regression model that we used analyzed the following patient features: temperature, PO2 saturation, leukocyte count, neutrophil count, and lymphocyte count. This is what the code looked like for the regression model. To build our web application, we used Flask implementation and simple HTML code. And in our Flask code file, we import Flask to implement our application, creating an upload file section and submit file section, include endpoints like health, predict, and upload, and we also added in our transfer model and regression models. For the HTML portion of our web application, this is our code, which takes in input from the user and also takes in an image as well, which can be submitted. This is currently what our application isCovid looks like to the user when they're using it.
We implemented two models, the transfer learning model and the random forest regression model. For structuring the dataset, we store the respective X-ray images retrieved from pre-processed CSV file into COVID negative or COVID positive folders. The images are scaled, normalized, and reshaped. We associated 1 for COVID positive and 0 as COVID negative. To facilitate the training of the model, we split the data into train, test, validate, as well as generated respective label arrays so that the model is able to know that if it classifies an image as 1 or 0. In other words, it can classify an image as COVID positive or COVID negative. Then we load the ResNet 50, which we use as our pre-trained model, and fine-tune it. Model configuration, we used batch normalization, as well as added a dropout rate of 0.2. This was after several experiments and research, which led to a best model accuracy. After that, we added our own fully connected layer and final classifier using sigmoid activation function. After training the model, we were able to get an accuracy of 98% and loss of 6%. For the random forest regression model, we first went through the data and replaced empty spaces in the column with average data in the column. For random forest regression model, our target field was whether the patient has COVID-19 or not, and then used other features like lymphocyte count, leukocyte count, neutrophil count, temperature, and PO2 saturation in order to predict whether the patient has COVID-19 or not. The random forest regression model is imported from scikit-learn. The fit function is used so the patterns in the data are recognized. Based on these patterns, a prediction has been made. This is a current working model of our web application. Here we first need to upload the image of our chest X-ray. Then we submit it. Now we put in the information regarding temperature of the patient, PO2 saturation, leukocyte count, lymphocyte count, and neutrophil count. After this, we put in the image name, that is the chest X-ray image name, and then we submit to get our results. So the prediction is positive. That means given the chest X-ray image and the information provided, the patient has COVID-19, and this is with confidence of 92%.
Lessons that we learned in our project was gaining skills on data science and Python and learning about its different libraries. We also gained skills and knowledge on machine learning and model building in Python and creating a web application using Flash web development. My role in our project was data cleaning, building a CNN model, and web application work. In the beginning, our first thing that we had to do was use a data set that we needed for our project. And the data set that we had in the beginning was messy and had missing and null information. We needed to get rid of the missing information and fix our data set before we could do anything else. This is the data set before, and this is our data set now. In order for our data set to get like this with no missing values, we had to use hot and encode. 1 meant COVID positive, 0 meant COVID negative. And we used it for gender as well. 0 meant female, 1 meant male. And for age, PO2 saturation, and temperature, we found the median values. And then after that, we were able to have 0 null values in our application. 0 null values in our application and get rid of unnecessary columns and data information that we didn't need. After that, we wanted to have a CNN model for image classification and compare it to the transfer model, but our CNN model wasn't fully complete. The problems that we faced doing our CNN model was the structure, finding accuracy, and imputing image stats framework. I had 2 different CNN models. One was more simple, one was more complex. The more complex one with more layers would have more accuracy compared to the more simple version. And lastly, at the end of our project, we worked with our coding Flash web development to create our web application, and also HTML code, and we had to implement the web application with the HTML code. Further work that we want to do, that we would like to do for the rest of our project, was further building onto the CNN models and compare it to the transfer model based on accuracy and which one would work better. Improve model performance on the CNN model and a more detailed web application page.
You can contact or reach out to us via email or LinkedIn. Thank you so much for listening to our Tech Talk today. We learned a lot. It was a journey of challenges, and we had a lot of fun too. Hope to hear from you in the future.